Okay, welcome to lecture number 26. Now, last lecture we have seen how to factorize the quadratic equation by improved guessing. Earlier lectures we have also seen that if the numbers are good, if the numbers are small, by inspection we can solve them. But then every time quadratic equations are not going to be so good that by inspection or method of improved guessing we will be able to solve them, and therefore we need to have a definite method by which we can say that doesn't matter what kind of quadratic equation it is, I should be able to solve it, I should be able to find values of x which makes it 0 without any problem. So today we will learn that particular method by which we will be able to solve every quadratic equation given to us, and then that particular method, the method that we will learn today, will take care of everything that we have learned earlier. So earlier it was little quick and easy, but now if the quadratic equations are little difficult, then how do we go about finding them out? However, what we will be really using, which will be the standard results which all of us are aware, that if first result, if a is a real number and if a is multiplied by 0, we get 0. This is the property of real numbers which we will assume to be true. If a comma b are real numbers and a into b is equal to 0, then this means either at least one of them. A comma b is 0. And if we extend this property, that if a1, a2, an are reals and if a1 into a2 into into an is equal to 0, then we can imply at least one of a1, a2 an is equal to 0. So these are the basic three properties that we will assume it to be true, and which all of us are aware that they are true. Now, if we ask you a question, x square minus 6x plus 6 is equal to 0, what are the roots or what are the values, real values of x which make this quadratic equation equal to 0, then no method that we have used so far, method of inspection, method of improved guessing, will not work in this case, and therefore we need to learn some new method by which, what is the problem here? The problem here is that I don't have any two factors of 6 which add up to, because of plus, which add up to 6, I don't have two factors, and therefore it is going to be difficult for me to find out. The roots of this actually are 3 plus root 3 and 3 minus root 3. So if we just cross check by putting x is equal to 3 plus root 3 here, you get a 0 in LHS, or if you put 3 minus root 3, you get 0 in LHS. So how do we really get roots looking like that? They are irrational roots, they are not rational roots, they are irrational roots. And in case of irrational roots, what should be the procedure of solving quadratic equation that we are going to learn now? Okay, so instead of doing so many numerical examples which are actually given in the lecture notes, method of completing square, basically method of completing square is the key which we have learned in last lecture, and that should give us the final answer. So we will take only one particular expression, or shall we do it in general? Let me do it in general and then explain you by taking a simple example how do we use generalized formula to solve any quadratic equation. So to start with, I will take quadratic equation ax square plus bx plus c is equal to 0. Now in this quadratic equation, a, b and c are real numbers. They can be any real numbers. They are not variables like x and x in this case. So ABC, I am representing the real numbers by the letters ABC, and therefore these ABCs are normally called parameters. They are not variables, they are constants, but they are not looking like real numbers, they are English letters, and therefore they are called parameters. So now I am going to go with method of completing the square, and because these A, B and C are not known to me, therefore I really do not know how do I complete the square. But then I have a method. What I do is I multiply by 4a times ax square plus bx plus c is equal to 0. Because I assume that a is not equal to 0, because a is not equal to 0, x square exists, x square terms exist, and therefore it remains a quadratic equation. If a becomes 0, then it is very easy to solve because it is not a quadratic equation. So I can always multiply LHS and RHS of given expression by non-zero constant, which is 4a, and hence this is perfectly logical step, which makes my given expression 4a square x square plus 4abx plus 4ac is equal to 0. Now I can look at these two terms and try to complete the square. First term is 2ax bracket square, so I need to write some constant here so that I get second term 4abx. Out of this 4, 2 comes from the multiplication of these two. Okay, so already 2 is there, so my problem of 4 is solved. A is already there, x is already there, therefore I must have only b here, bracket square. So I have guessed now this particular expression. If I try to complete the square, the first term must be 2ax plus b whole bracket square. Now I cross check, square of this is this, and second term product of these two into 2 is 4abx, but I have unnecessarily generated b square, which I subtract b square plus 4ac. Now this should be equal to 0. These two are the same expression, same LHS. Now this gives me 2ax plus b bracket square minus, if I take out common, I get b square minus 4ac, which is equal to 0. Now I have to look at it as difference of two squares, therefore 2ax plus b bracket square minus square root of b square minus 4ac bracket square is equal to 0. Okay, therefore now I get two factors, 2ax plus b minus root of b square minus 4ac is the first factor, and 2ax plus b plus root of b square minus 4ac as a second factor should add up to 0. This gives me this factor could be 0 or this factor could be 0, which implies 2ax plus b is equal to root of b square minus 4ac. This implies 2ax is equal to minus b plus root of b square minus 4ac, which implies x is equal to minus b plus root of b square minus 4ac upon 2a. Now again, a is not equal to 0, therefore I am authorized to divide by 0. And now if I take second bracket, I get 2ax plus b is equal to minus root of b square minus 4ac, which implies 2ax is equal to minus b minus root of b square minus 4ac, which implies x is equal to minus b minus root of b square minus 4ac upon 2a. So if this was a quadratic equation given to me, then it has two roots, which are x is equal to minus b plus minus under root b square minus 4ac upon 2a. So we have done it. So we have factorized. So now the only question is, will this always be a real number? Now for different values of a, b and c, this quantity is going to be different every time. Now the only trouble that we have in the final expression is that there is something inside radical sign, which is b square minus 4ac, and therefore this b square minus 4ac is called discriminant, normally denoted by delta, which is b square minus 4ac, and it discriminates between the roots of quadratic equation ax square plus bx plus c, and therefore it is called discriminant. It differentiates, it separates different quadratic equation from being real and our roots are imaginary. So basically, if b square minus 4ac is equal to 0, then I have two roots which are b minus a by 2 minus b by 2a and minus b by 2a. So both the roots are same. So if discriminant is 0, quadratic equation is a perfect square, and hence both the roots are same. If discriminant b square minus 4ac is greater than 0, then you end up having two distinct roots, because plus b root b square minus 4ac and minus root b square minus 4ac will make two roots look different. Therefore it will have two distinct roots if b square minus 4ac is greater than 0, and if b square minus 4ac, third case, is less than 0, then we are in trouble. We will not get any value of x which is real, because radical square root of negative quantity is not defined in real numbers. We need to learn complex numbers for finding out roots of them. So this is what is important, that b square minus 4ac will decide your roots. Now let us take example which we left earlier. X square plus minus 6x plus 6 is equal to 0. Here the value of a is 1. Value of a is equal to 1. Value of b is equal to minus 6. And value of c is equal to 6. Therefore, let us put those values back into this equation and find out what is the value of x. So b is minus 6. Therefore, plus 6 plus root of, now b square, that is 36, minus 4ac minus 24. So 36 minus 24 is 12. So I get 12 here, divided by 2 times 1 is 2, which is, now 4 will come out with 2, this 2 will get cancelled, and this is equal to 3 plus root 3, which we got, which we had said that this is one of the roots. And if we substitute all of that over there, we get 6 minus root 12 upon 2, which is 3 minus root 3. So practically, if you happen to have b square minus 4ac 0 or greater than 0, you will end up having roots, maybe rational, maybe irrational, but always there. And we have found out that it satisfies. Therefore, this is the general method. This proof is important. You try your level best to remember this proof. Write it several times, and you need to remember this formula: x is equal to minus b plus minus under root b square minus 4ac upon 2a by heart. It is important. Remember forever, because solving quadratic equation is very, very important. I hope you have understood this particular lecture. We have got many more problems in the homework which you should solve and be really very fluent with quadratic equations. Thank you.